Hi there, let's have a look at this transformation question. So this tells us that the transformation t from the z plane to the w plane is given by this equation here. So this is how it's going to map on a value of z to a value of w. And it tells us the circle with equation modulus z equals 1. So that's our unit circle in the z plane is mapped by t onto the circle c in the w plane. Determine the centre of c and the radius of c. So to get started, we're going to have to rearrange our equation to get z in terms of w, and then we can use what we know about z here to then work out what the circle is going to look like in the w plane. So let's multiply by the denominator, so w times z plus 2i is equal to z minus 3i, expand, 2iw is equal to z minus 3i, and then this is as we're GC1, so we're going to get everything in terms of z, so get all your z's on one side, so wz minus z is going to equal minus 3i minus 2iw, so that I can then factorise on this side. So this comes up quite a lot, especially like GCSE catches quite a lot of people out. So now I can rearrange this for z. So I'm going to take out minus I. So that's going to be 3 plus 2w all divided by w minus 1. And now from the question we know that the modulus of z is equal to 1. So if I do the modulus of both sides, I'm going to get 1 is equal to the modulus of this side. Now, in terms of a few modulus rules that we can do, or properties that we can do, so this top bit, this minus I, is not going to contribute anything, it's got modulus of 1. So I'm going to get the modulus of 3 plus 2w divided by the modulus of w minus 1. And that's one of your modulus properties, modulus of a over b, is modulus of a over the modulus of b, and same with a product as well. So modulus of ab is modulus of a, modulus of b. I can then multiply it by the denominator and I get modulus w minus 1 is equal to the modulus of 3 plus 2w. I'm then going to square both sides just to make this a bit easier, because I know the modulus squared is equal to the real part squared plus the imaginary part squared. Now we can conventionally label z as x plus iy, so I'm going to write w is u plus iv, although you might want different letters to not get mixed up, so maybe something like alpha plus I beta. So this equation is going to become, so then this is going to become, so minus 1 obviously is a real number, so that's going to become alpha minus 1 squared plus beta squared, and then it's going to be equal in terms of the right hand side. I've got to be a little bit careful because there's 2, so actually I'm just going to do a bit of side work here. So 3 plus 2w squared, that's going to be the same as 3 plus 2 alpha plus 2I beta squared. So that's 3 plus 2 alpha squared plus 2 beta all squared. So 3 plus 2 alpha squared plus 2 beta squared. Expand out with brackets, alpha squared minus 2 alpha plus 1 plus beta squared is going to equal 9 plus 3 times 2 is 6, and then times by 2, 12 alpha plus 4 alpha squared plus 4 beta squared. And I want to rearrange this for 0, and then I can shift my numbers to get it looking like equation of a circle. So I've got more alpha squared and beta squared on this side, so I'll make 0 on the left hand side. So take away an alpha squared and a beta squared, I'm going to get 3 alpha squared and 3 beta squared. Instead of the 2 alpha, add that, so I'm going to get 14 alpha and then take away the 1, so I get plus 8. So I've got 3 alpha squared plus 14 alpha plus 3 beta squared plus 8 is going to equal 0. And I want to complete the square on the alpha terms. That's what we typically do to get the equation of a circle. So alpha squared plus 14 over 3 alpha plus me 3 beta squared plus 8 equals 0. And then let's actually do the completing the square. So that's going to be 7 over 3 squared minus this term squared, 49 over 9, plus 3 beta squared plus 8 equals 0. So 3 alpha plus 7 over 3 squared minus 49 over 3 plus 3 beta squared plus 8 equals 0. I'm going to change that 816 to 24 over 3. So then I've got 3 alpha plus 7 over 3 squared plus the 3 beta squared. And then minus 49 over 3 plus 24, that's minus 25 over 3 equals 0. So then 3 alpha plus 7 over 3 squared plus 3 beta squared is equal to 25 over 3. Divide by the 3. So alpha plus 7 over 3 squared plus beta squared is equal to 25 over 9. So my centre, my circle, is minus 7 over 3 for x and 0 for y. And then my radius is going to be the square root of this term, which is just 5 over 3. There we go. So a lot of algebra, a lot of procedures that I should be used to doing, completing the square, expanding brackets, rearranging formulae. Nothing too much there. And just using the fact that we're told that z is on the unit circle.